In problem 3, we have another algebraic equation to solve. Now, normally, a good rule of thumb is when you're dealing with an equation that contains fractions, you can eliminate the fractions in your first step by multiplying both sides of the equation by the LCD, the least common denominator. In this case, that would be 12. I'm going to skip that step because in this case, if we distribute the fractions, the resulting equation will be containing only whole numbers. 1/4 times 8 is a whole number, 1/4 times -20 is a whole number, likewise on the right hand side. So I'm going to start off this equation by distributing the 1/4 to both terms inside the parentheses on the left and distributing the 1/3 to both terms inside the parentheses on the right. So 1/4 times 8x, or 8 over 4, will give us 2x. And 1/4 times the -20, well, 20 over 4 is 5, so that's a -5. On the right-hand side, 1/3 times 15, or 15 over 3 is 5, so that's 5x. And 1/3 times a -6, so 6 over 3 is 2, so that's a -2. So we distribute the fractions, we end up with 2x minus 5 is equal to 5x minus 2. We want our x's on one side, numbers on the other. It doesn't matter which side your x is on as long as x is isolated on one of the sides. I'm going to keep the x's positive, so we'll bring all the x's to the right. There's more x's on the right hand side. So we can subtract 2x from both sides. This will eliminate the x's on the left. So we have a -5 is equal to 3x minus 2. We have x's all on the right hand side, so now we'll bring the numbers to the left. Get rid of the -2 with a +2. Add 2 to both sides. So we've got a -3 is equal to 3x. We want x by itself. We want to eliminate the times 3, so we can divide by 3. Divide. This will eliminate the 3 on the right. So we'll have -1 is equal to x. We've got x by itself. That was our goal. So for this problem, x is equal to -1. Again, as with the last problem, we could plug a -1 in for x and make sure we get the same value on both sides of the equation. Make sure it's right.